Setting the scene, picture this: a massive tornado spinning its way toward a city skyline. Skyscrapers tower into the clouds, concrete and steel stretching hundreds of feet tall. It's natural to wonder, could those colossal structures block the storm? Could they act like shields, breaking apart the swirling winds before they reach the ground? It's an idea that pops up all the time, especially after big tornado outbreaks. People ask, if tornadoes destroy small towns, why don't they tear through major downtowns filled with skyscrapers more often? The truth is fascinating, and the science shows that skyscrapers don't stop tornadoes. In fact, their presence has surprisingly little effect on these monstrous storms. To understand why, we need to dive into how tornadoes work, how cities interact with weather, and what actually happens when violent storms meet the skyline. How tornadoes form. At their core, tornadoes are born from supercell thunderstorms, massive rotating storm systems that can tower over 50,000 feet into the atmosphere. Inside these storms, strong wind shear changes in wind direction and speed with height creates horizontal tubes of rotating air. When a thunderstorm's powerful updraft tilts and stretches that rotation, it can funnel downward into a tornado. A fully developed tornado is a rotating column of air that extends from the base of the cloud all the way to the ground. Some are weak and short-lived. Others, like EF4s and EF5s, pack winds exceeding 200 miles per hour and carve paths miles wide. The key point here is scale. Tornadoes are atmospheric events, not surface-level breezes. The energy driving them comes from the storm miles above the earth, not just the ground. That matters when we compare them to buildings. The scale problem: tornado versus skyscraper. A tornado can reach over 10 miles tall. A skyscraper, even the tallest in the world, tops out at just over 2,700 feet. And that's an extreme outlier like the Burj Khalifa. Most American skyscrapers, like those in Dallas, Chicago, or New York, average between 600 and 1,400 feet. So, while skyscrapers feel enormous to us, they're tiny obstacles in the path of a tornado. Imagine a pencil standing on a basketball. That's about the scale of a skyscraper versus a supercell storm. When tornado winds slam into buildings, they don't stop or deflect the tornado. The winds simply rush around, over, or through the obstacles, maintaining their rotation. The storm system feeding the tornado is too massive and powerful to be disrupted by anything humans have built. Urban tornado myths. There's a common myth that tornadoes avoid cities, rivers, or mountains. The reality? Tornadoes can and do strike anywhere, though the odds are lower in densely built-up downtowns for a few reasons. Geography of the plains. The U.S. Midwest, where most tornadoes occur, has sprawling flatlands dotted with smaller towns, farms, and suburbs rather than skyscraper-filled cities. That makes cities a less common target. Size of downtown areas. Even large cities only have a small core with skyscrapers. A tornado's path can be miles wide, so even if it heads toward a metro, it's statistically more likely to hit outer suburbs, industrial parks, or residential areas. Probability, not protection. The rarity of direct hits on skyscraper districts has led people to believe urban cores are somehow immune. But history proves otherwise. Tornadoes that did strike cities. Several real-world cases show tornadoes don't hesitate when it comes to cities. St. Louis, Missouri, 1896, 1927, 2011. Multiple destructive tornadoes have struck St. Louis, including one of the deadliest in U.S. history in 1896. Fort Worth, Texas, 2000. A strong tornado hit the city's downtown, breaking windows and damaging high-rise buildings. Nashville, Tennessee, 1998 and 2020. Tornadoes have ripped through parts of downtown, proving urban skylines don't repel storms. Atlanta, Georgia, 2008. An EF2 tornado cut directly through downtown, damaging the Georgia Dome, CNN Center, and several skyscrapers. In each case, the tornado carved through the city as though the skyscrapers weren't even there. Windows shattered, facades were ripped away, and debris flew. But the tornado itself kept going. What actually happens when tornadoes hit buildings? When tornado winds meet a building, several things can happen. Wind channeling. Tall buildings can funnel wind between them, increasing local speeds. That can create dangerous wind tunnels, but it doesn't weaken the tornado overall. Debris creation. Skyscrapers and high-rises are made of glass, metal, and concrete. When struck, they can turn into massive debris fields, feeding the tornado's destructive power. Localized damage. While a tornado won't be stopped, skyscrapers can influence the immediate wind field, creating swirling eddies and chaotic gusts around street level. This can make survival on the ground even more complicated. So instead of stopping tornadoes, skyscrapers may actually amplify risks for people caught in the wrong spot. The physics of why they can't stop tornadoes. To stop a tornado, you'd need to interfere with the entire storm system feeding it, not just block the winds at the surface. Tornadoes are fueled by warm, moist air colliding with cooler, drier air high above, plus strong vertical wind shear. That energy exchange happens on a scale far beyond city limits. Think of it this way. A skyscraper is like a small rock in a river. The water flows around it, maybe with some splashing and turbulence, but the river keeps going. A tornado is the atmosphere's river of air, and skyscrapers are just pebbles. Even dozens of skyscrapers clustered together can't alter the massive inflow and outflow dynamics of a tornado. Could future cities be designed to resist tornadoes? While skyscrapers can't stop tornadoes, urban design can help minimize damage. Stronger building codes, reinforced glass, aerodynamic shapes, and deeper foundations can make skyscrapers more resistant to high winds. Underground shelters. Cities can invest in more storm shelters or fortified underground spaces to keep residents safe. Smart infrastructure. Future materials, like flexible composites, could reduce the risk of catastrophic collapse. But even with these measures, no city can engineer its way out of the risk completely. Tornadoes are simply too powerful and too large to be negated by human construction. Why we rarely see skyscrapers obliterated. 1. Reason tornadoes and skyscrapers don't often collide head-on is simple probability. The densest parts of cities cover a very small geographic footprint compared to the sprawling suburbs. Since tornadoes can form anywhere across wide regions, the chance of one passing directly through the high-rise cluster of downtown is relatively low. This doesn't mean it can't happen. It just means that when we see tornado destruction, it's usually residential neighborhoods, factories, or small towns, not 50-story towers. What if we built giant walls? Another idea people suggest is constructing massive walls or barriers around cities to deflect tornadoes. In theory, walls could disrupt surface winds, but in practice, the atmosphere doesn't work that way. Tornadoes are driven by energy thousands of feet up. Even if you built a wall hundreds of feet high, the storm would simply reform on the other side. Scientists agree that trying to build tornado defenses on that scale would be futile. It's better to focus on prediction, warning systems, and preparedness. The real protection against tornadoes. Since skyscrapers can't stop tornadoes, what can? Advanced radar and forecasting. The biggest lifesaver has been early detection. Doppler radar and storm-chasing science now give people more warning than ever before. Warning systems. Sirens, smartphone alerts, and weather apps alert communities when a tornado is approaching. Safe practices. Knowing to seek shelter in basements, interior rooms, or storm shelters makes the biggest difference in survival rates. Technology can't stop tornadoes, but it can save lives by keeping people out of harm's way. Final takeaway. So, do skyscrapers stop tornadoes? The short answer, no, not at all. Tornadoes are atmospheric beasts powered by forces miles above the ground, and skyscrapers are tiny obstacles in comparison. When tornadoes do hit cities, they treat skyscrapers like any other structure, smashing windows, peeling facades, and creating debris, but continuing on their destructive path. If anything, cities add new risks: wind tunnels, flying glass, and massive debris. The only real protection comes from forecasting, warning systems, and safe shelter practices. In the end, tornadoes remind us of nature's scale. Our tallest buildings might scrape the sky, but compared to the atmosphere's fury, they're just specks on the landscape.